This is A2physics 5, May 07, and this is a capacitor question, and it's question 1. 1a. Figure 1.1 shows a circuit to enable the capacitance of a capacitor to be determined by measuring the time constant tau. Now, this is the first time we've had a time constant question. The resistance of the resistor is 47 kilo ohms. With the switch S1 closed, the voltmeter reads 18.2 volts. S1 is opened, and after 45 seconds, the reading on the voltmeter drops to 6.7 volts. Show that the time constant of the circuit is 45 seconds. Now we know a calculation for the time constant is CR, but we don't have a value for C. And so we can't use that. So the other alternative is that they're saying after 45 seconds the reading has gone down to 6.7 volts. So we know after a time constant of a circuit the reading should have gone down to 37% of its original. So what we're going to check is 6.7 37% of 18.2. So if this is if tau equals 45 seconds, then 6.7 over 18.2 should be equal to 37%. And therefore we're just going to check that 6.7 over 18.2 multiplied by 100, and it does give you 37%. So that gives you 37%. The other alternative is you could just take 18.2 and take 13% of it, 37% of it, multiplied by 0.37, and that does give you 6.7 volts. So that's two ways you could do that to get your 1 mark. Calculate the capacitance of the capacitor. So you know that tau is equal to CR. So therefore C is equal to tau over R. Tau is 45 seconds. R is 47 kilo ohms, so that's by 10 to the 3. And C comes out to be 957.4 microfarads. Or given that they have everything here to the biggest number of significant figures is 3, we'll write 957. So it's 957 microfarads. This part B, the 470 microfarad capacitor in figure 1.2 is first charged by closing the switch S1, which connects it to a 12 volt supply. So this is charged then to 12 volts. The switch S2 is open. Calculate the charge stored in the 470 microfarad capacitor. And therefore we're just going to use Q is equal to CV, and that's 470 microfarads multiplied by 12 volts, and that gives you an answer of, I've just left it with the micro in it, 5640 microcoulombs, or that's 5.64 by 10 to the minus 3. Next part of the question, calculate energy stored in the 470 microfarad capacitor. So just using A is equal to half CV squared, that's a half times 470 by 10 to the minus 6, and then V squared is 12 squared. And that gives you an answer of 0.0338 or 33.8 millijoules. So just watch out for wee things like that where they're expecting you to use a prefix in your answer and you mightn't have just caught on. You'd lose a mark for that if you didn't have that. Part 3, S1 is now opened, disconnecting a 470 microfarad capacitor from the supply. S2 is then closed, connecting the charged 470 microfarad capacitor to an uncharged 220 microfarad capacitor. So I'm just going to draw this down at the side. So you've got your 470, which is charged, now in parallel with your 220. Whenever this happens, you always assume that they are in parallel. So calculate the resultant potential difference across a 220 microfarad capacitor. So if we use C is equal to Q over V, so V is equal to Q over C. So we can calculate the charge which we have in the last bit from part B, part 1, Qt is equal to 5.64 by 10 to the minus 3 coulombs. So we know that already. We're going to use that in here. Calculate the total capacitance. The two capacitors are in parallel, so that's 470 plus 220, which gives you a total of 690 microfarads. I'll just put a wee micro in there in case you're not sure. And therefore we can do V is equal to Q over C, and Q is 5.64 by 10 to the minus 3, and C is 690 by 10 to the minus 6. And V comes out then as, to three significant figures, 8.17 volts. Last part of the question, calculate the total energy stored in the two capacitors. And so we'll just use A is equal to half CV squared and use the total voltage in the total capacitance. So that's a half. Total capacitance is 690 by 10 to the minus 6. Total voltage is 8.17 squared. And that gives you an answer of 0.023 joules. Again, they're looking for an answer in millijoules, so you have to change that into 23 millijoules.